Statistical significance means that we can be confident that an effect that we've seen in the sample is a real effect in the population. Let's imagine that in our sample we see a difference of 3 centimeters between the average heights of men and women. Well, it's possible that could be a false positive. So there could be a difference in the sample, but no difference in the population. So we begin with something called the null hypothesis. We begin by assuming that there's no difference in the population. It's possible, but is it probable? We work out a number called the p-value. The p-value is the probability of seeing that effect, that difference, or a larger difference, assuming that the null hypothesis is true. And if that p-value is low, if that probability is low, then we can take our null hypothesis and throw it away, reject it, in favor of what's called the alternative hypothesis, that there is a real effect in the population. How unlikely does it have to be? How low does that p-value have to be? We set a number called the alpha level. The alpha level is the highest acceptable risk of a false positive. Conventionally, it's set at 5%, so 0.05. And what that means is that if the p-value is below the alpha level, below 0.05, then we can reject the null hypothesis and be confident, yes, it is a real effect in the population. I'm going to show you how it works behind the scenes. So, the null hypothesis is that there's no effect. The effect is zero difference. But different samples will say different things. We can use the standard error from our sample, which is in this case 1 centimeter, to imagine a sampling distribution, what the sampling distribution would look like if the null hypothesis is true. So, if the null hypothesis is true, then the mean of that sampling distribution will be 0, no difference. If the null hypothesis is true, then 95% of the data points will be within 1.96 standard errors of 0. If the null hypothesis is true, there is a less than 5% probability, p less than 0.05, of seeing an effect at the extremes of that distribution in those darker red areas. That's called the critical region. And therefore, if the effect is within that critical region, then we say p is less than 0.05, reject the null hypothesis. And here we can see it is. That difference is within the critical region, p is less than 0.05, therefore we can reject the null hypothesis and be confident that there's a real difference in the population. And that is statistical significance.